let's start second workshop in this session. The second workshop is recovery, identification, and the study of the meteorites presented by the Bhandari and the Adur. Please start your workshop presentation.
Right, sir.
Thank you.
The stage belongs to you.
Yeah, thank you very much. You see, we spend billions of dollars trying to get rocks from different places in our solar system, from different planets. And nature is very kind. It brings them free to our doorsteps. But we are not very careful, and most of them get lost. So this workshop, which we present on behalf of our astro enthusiast group, is meant for getting you interested in collecting meteorites. They have tremendous scientific value. Also, they are very useful in understanding how our planet, solar system, our universe was formed. So apart from scientific importance, we have a lot of excitement if you hold a cosmic rock in your hand, or if you see a cosmic phenomena. It is a out of the world experience. It is a lifetime experience which we always remember. And therefore, I want to talk about this, how to collect meteorites, and we want to form a group worldwide which will help get these precious samples in the laboratory. Because unless the stones are examined scientifically and analyzed, they are just some rocks of no value. So I'll try to share the screen now and show you some slides. Okay, I hope you can see this.
Sir, kindly make it a slideshow, sir. Just click on the slideshow.
Okay, I'll do that.
Animations, slideshow.
Yeah. Slideshow. So I started.
Play from the start. So play from start. You have to click at the first icon. Just below home, sir. Below home. Play from. No, sir.
Or press F5 button to start the slideshow. F5 button
Yes,
on your keyboard.
Yes, sir.
Okay.
Is it okay now?
No, sir.
No.
Sir, you can press the first button, which I can see play from start.
Play from start. Just below home.
Okay.
Yeah. This one. Yeah.
Okay.
Yes, sir. Perfect.
Okay,
so
perfect.
When we look at the night sky, we can see stars and planets and so on, indicating that actually sky is empty and there is no obstruction between us and the planet. That is how we can see it. But that is not true. We live in a very crowded space, and there are millions and billions of stones around, only they don't obstruct our sight, so we can see various objects in the sky. So here is our solar system, and the Earth and Mars and so on, and there is an asteroid belt, as you all know, Jupiter, Saturn and so on. And as you go beyond Neptune, you have another belt which has a lot of stones. Now these stones sometimes make their way back to Earth. So the space is three-dimensional. Chance of meeting them is very small. But once in a while, due to perturbation, gravitational perturbation of various planets as they move around, we have these rocks come and fall in the on the Earth. Now the evidence for this is the map of the Earth, our globe, and you see these spots, they are all craters. So we have lots of craters in the past. That means lots of materials have been rocks have been falling here, but there is a large area where nothing has been found here in South America, in Africa, in so many places. That is not because they are not falling there. We expect them to fall uniformly, but because they got obliterated because of volcanism and desert and rain and all this kind of terrestrial phenomena. So only few get preserved. Now here I show you a curve that every year some 1100 meteorites fall on the Earth. That is the estimate based on crater counts on the moon and counts of the rocks in the sky and count of the craters on the Earth and so on, all mixed together give us this curve. So every year we have about 1100 rocks more than size of a fist you can hold in the hand, maybe a kilogram or more, half a kilogram or more. But 2/3 of course go and fall in the ocean, and of the rest 50% may be falling in the remote areas. So at least 100 rocks must be in collectible regions, but we are very careless about these precious rocks. And I want to really excite you about their scientific worth so that we can make a global network and not miss a single one which can be collected. Now these rocks travel with tremendous velocity, kilometers per second, several tens of kilometers per second. So half mv square, the kinetic energy is enormous. So you see we have this curve I have taken from Chapman's old work, and the Hiroshima was 20 kilotons. That kind of rock falls once every year. But fortunately we have the atmosphere, so most of it burns in the atmosphere and only a small part comes down. The next big hazard in 2036, far away, so we can be very lax about it, we don't have to worry. But I am more worried about these rocks which we are not collecting. Now you see the rocks give, when they enter the atmosphere, as I said, they burn. So 4 phenomena are observed, 2 in the atmosphere and 2 on the ground. You see a fireball, a bright light, it is a night time, but you still can see shadow. So it is brighter than full moon. This is the one which came on Valentine's Day on the Earth a few years ago. So the very fact it came on a Valentine's Day means it likes the Earth, very much. And so we have to be careful because the large ones can be very troublesome, and I'll come to that in a minute. Now this is another one which fell about 40 years ago in Gujarat, and you see this blue region, that is where the sound is heard, and the yellow region is where the light is seen, several 100 kilometers across. This is about 400 kilometers. So you see light from far away and sound in a limited region, and there are 2 types of sounds. One is a hissing sound like that of many cobras hissing together, like this, very frightening if you are just underneath the trail of this meteorite. And the other is the explosion site if it breaks in the atmosphere. Now this one had broken, and this is how it makes a strewn field or we call it a fallout ellipse. The smallest fragments fall at the the trailing end, and the largest rock, which was 12 kilogram, fell at the leading edge. So we collected about 500 stones like this. And this is one very famous crater. It's about 2 kilometers across and 200-meter deep in Maharashtra in India. And the big ones actually can destroy a whole civilization, whereas the small ones give us life giving compounds. So it is useful to us. It gives us life. It brings phosphate and volatiles and amino acids and fatty acids and many organic compounds. But the big ones are really destroyers. So nature uses the same technique to destroy us and to create life on earth. So this is a very interesting phenomena, and some of them explode in the air. This is a Tunguska event in Siberia in 1908, and such events occur about once in 100 years. So it is about time we should notice another event like this. This fell on June 30th, which we observe as a asteroid day to remind us that these are very important objects and we should not just neglect them, but be careful. Now, if we go and look for meteorites, we must know how they appear. So there are three types of meteorites. One is the iron meteorite, other is a stone meteorite, the lower one, and in the middle is a mixture of stone and iron. Now, iron meteorites and stone meteorites are different. Stone meteorites are formed by collection of dust grains, and you see it has these round balls here. You can see a very huge, about half a centimeter across, a round ball. These distinguish these stone meteorites from others. And these iron and iron stones are melt rocks. But 93% of all rocks falling, that is the largest fraction, is stones. So when you see a rock falling, most likely it is a stone, and very rarely it is a stony iron. Now I show you various pictures of these stones. This is the famous Murchison Meteorite, which was the first one in which amino acids were detected. A carbonaceous chondrite. It has about 2% carbon and about 8% water. This is another Alande meteorite. They both fell in 1969. This is an iron meteorite. You see these little spots, the thumbprints you can see here also. And some of the meteorites are having flow lines. You can see very clearly because they have minerals which flow very easily. They form these flow lines. This is a rock from moon which has come as a meteorite, and you see angular fragments all compacted. This is a meteorite from Mars, the famous Shargoti meteorite. So you see we get samples from moon and Mars and other planets, and this particular one is a Pipolia meteorite which came from the, we believe, asteroid Vesta. We identified it because it has the same spectra. The Vesta asteroid has the same spectrum as this rock. Some break on ground, and this is the one which fell near Jaipur. It is more or less like this, but it broke into hundreds of pieces. This, if you polish, you see gem-like minerals, olivines and all that. And these are the balls we recovered from a meteorite. And this is the polished section of an iron meteorite like this. If you take and polish it, which is very hard. And this is sometimes you get a crater in the ground. So this is a soil. And when this meteorite, Mukundpura, fell, it created a crater. So surface features, interior features, ground features, polished section features, they enable us to identify a meteorite from a earth rock. And so there are falls which you see falling, and there are finds which you see which have fallen long time ago, and you find them. And there are two types of things. One is fresh falls, and if you see, there are various ways to identify. You see a fusion crust because of burning, a black brown fusion crust, thumbprints. Density is very high, 3 to 3.6 gram for stones and about 7 grams per cc for irons. Magnetism, they have magnetism. There's a smell. Their shape is very rounded and peculiar. There's a shiny metal in them, and some minerals are there, and these balls I talked about. So we have these many features, and you see we took an expedition. It required lots of people, and actually school children are very helpful. So we had lots of about 200 school children, and they were all walking through the this run of Kutch, which was talked by the previous speaker here. You see far away, about 10 feet apart or to 6 feet apart, and almost everybody, all the 200, got a small piece for himself. And of course we collected and sent to Geological Survey of India, 75 kilograms of it. Now in Antarctica, they have found about 25,000 meteorites, some from moon, some from Mars, some from asteroids, and so on. And we found one in Rajasthan desert, and in Sahara lots of things have been found. So what we have to do is we have to be prepared, and this will be talked by Dr. Bharat Adur. You can put a video camera on your roof of the house which operates in the night, or a audio camera, audio recorder, or on the car you can put it. Lots of people see it when there is a trail, and you can recover them in the field by taking an expedition, and then you can do some analysis, density, microscopic studies, and you can classify a meteorite, and that is when serious science starts. So your kit must contain a magnet, a magnifying glass, a hammer, a chisel, a compass, a camera, a measuring tape, some plastic gloves to keep them safe, because we have learned a lot of things from these meteorites, when our sun and planets were formed, how the stars are formed, how they explode, what are the nuclear reaction, what are the phases or stages through which our solar system went through before we had this harmonious planetary systems, when and how the life originated on Earth, where from we got amino acids, how the molecular clouds are, and what moon and Mars composition is, and asteroids. And most of all, we learned a lot about cosmic radiation. So we want to invite you to join us. We need about 6,000 volunteers to cover the Earth, because in your lifetime, one meteorite is sure to fall in 100 kilometer radius. So if you keep your eyes open and ears open, you will surely find a meteorite, and you can collect one of your own and hold a cosmic rock in your palms and get it examined in a laboratory. You know, in the olden times, this is Emperor Jahangir, who was the Emperor of India. He didn't know what to do with meteorites, so he made a dagger of iron meteorite he found. But we are, I think, more scientific oriented, so we can analyze and find a lot of things about solar system. And this is a cloud, molecular cloud, out of which our solar system was formed. And we can learn, because meteorites have even grains from molecular clouds carried all the way to Earth. So this is I wanted to say, and invite you to become a meteorite hunter. It doesn't take much effort. It only needs that you are vigilant and look for these rocks when they fall in your vicinity. And we can learn a lot of science and have a lot of excitement. So join our group, and we need thousands of them, maybe at least 6,000 to cover the whole world. Thank you very much. I will stop here, and Dr. Adur will take over.
Thank you, Bhandari sir. And Adur sir, I would request you to kindly unmute yourself so that the presentation can carry on. And so, friends, we have just heard from Bhandari sir regarding the preliminaries. Bhandari sir, can you kindly stop sharing the screen so that I can share it?
Surely.
Okay. So I hope that this screen is visible to you all.
Yeah.
Okay. Yes, sir. Bharat, Adur sir, you can just define your part, that is, give the synopsis, and then you can just keep on saying next slide, and I will keep on flipping the slides.
Yeah. Thank you. Thank you very much. As Professor Bhandari has already talked about what kinds of meteorites are available and in what all formats. And one of the things which we have been trying to pursue is identifying recovery of fireball as well as meteors. The reason being, identification starts when you see a meteor shower which falls from the sky, and you are able to identify which part of the sky it has fallen. Earlier, we used to conduct meteor observation where we used to give them sky maps, and on the sky map, they were told to make the marking from which star of that particular constellation till what star it has ended. So that was one exercise we used to do with sky maps, or rather star maps. And this was one way of identifying meteors falling and then how to recover. Yeah, it is a little bigger exercise, but now we have a lot of equipment, or rather even in our mobiles we have GPS, by which we are able to identify also the place. At the same time, when you see it in the sky, you can plot it on your map and then carry it forward. So this is one area where you can start actual identifying the meteor from which object. Most of the time earlier, in the early 80s and early 90s, we used to only do visual mapping of the meteors, and there the only thing that we had to give was sky maps. And on the sky map, even school children could plot the meteor shower, how it falls, where, and then the color of the meteor also was very interesting. So people could actually associate themselves with the sky. So this was one exercise of looking for meteors. Fortunately, now we have a camera which is able to look at the whole sky and pick up these meteor showers. And again, we can analyze them and find out what is the extent of it. So this is one part of it. Now, after the meteorite has fallen, or in many cases, when you have a meteor shower, it doesn't happen only one event. What we call it as a lot of meteor showers are falling from one particular part of the sky. The most interesting was Leonids, which originates from the Leo constellation, and the latter was Geminids. So these two were then the focus of looking for meteor showers. Now further, can we have the next one? The objective in all this is, after it is falling, it is just not a ball which is falling, it is a rock which is falling. So obviously it will have an impact on the ground. You may have seen a putt shot, when you throw a putt shot and when it falls on maybe a wet soil, you will find that putt shot also makes a form of a crater. So you don't need an actual meteorite to come and hit. One can use putt shots on wet soil, and you can see how they form craters. Now, this is one ideal way of seeing the craters formed on the soil or rather wet soil, and then similarly you can extrapolate it further. But one thing you must remember, even when a putt shot ball comes and hits the ground, there is some kind of a vibrations which are there for people who are watching that putt shot falling. So again, that comes as a part of your exercise of how the our earth or the soil behaves, and then the vibrations are carried forward. And these vibrations, one can see it for a very long distance. So I have put some names here: ultrasonics, seismic, gravity, and magnetics. All this today one can look at it more carefully. And you can find that these waves which are formed on the soil are conveyed further. And in that, you do find two types. One is the primary wave, and the second is the secondary wave. So these kind of waves are formed due to the impact of a putt shot and or a meteorite when it falls. Now these are definitely required for looking at impact craters. Its impact crater is, as Professor Bhandari has shown, that it has a pear-like shape or a tear-like shape, where it has a beginning and then it has a large bulge. At the bulge, you are able to see larger and larger meteors or meteorites in the ground. So this is one where we are talking about the methodologies adopted is to understand these waves. And it doesn't only happen on the soil. It happens on the substrata or these material on which it falls. For example, in Lonar, when it fell on a basalt. And this is the only second largest crater which has been formed on Lonar. And as the stone went, as the meteorite went below, it created some formations on the rim of the crater. So one can see even that, and also since the pressure and the temperature is so large that the rocks over there also had felt the impact of it, and many of the rocks had become glassy. One of the most interesting paper on which we worked was by Professor Bhandari, where he pointed out where the glassy stones are there, where the other craterlets could be there. So Lonar alone doesn't have one crater. It has more than 5 craters that we have seen. One is the Lonar itself, and very close to Lonar, there is a mini Lonar crater, which is also there. And then near the peripheries, there are smaller and smaller craterlets. Also, one can see it. So, these are the observations which one is able to see. And one more, please, is an important issue. When you are looking at a crater, please look at it as a scientific event where a large meteorite, maybe of a 10 to 20 kilometers diameter, has come and crashed onto the earth. One of our students had done this work, and he has found that after the meteor had hit at Lonar or Buldana, the earthquake vibrations had reached all the way up to the north, as well as towards Bombay also. So these are the observations which one can get for a crater which is right there in India, in Maharashtra at Buldana, which is really a very interesting object to look at. Plus, you are still able to find micrometeorites. That means the crust component of that large meteorite which blew up or burst open And then it is now at the lake level, one can find this. It's not very difficult. All that one needs is a small round magnet or a bar magnet, and you are able to pick up these micrometeorites. At some places, we had done a full analysis. In fact, Amrutanshu, can we see the next slide? These are the found meteorites I want to show you, which have been from Koba. I think one of our members, Pratik, had also pointed out this. It's in Namibia, and it is still there. But the reference of that meteorite is there, but the other parts of how that large stone was not crushed, but it is in one piece. So like that, there are a lot of, but the weight at that point was 60 tons. And if you see that all these places, the found meteorites have been there, and you will see the weight. The weight is tremendous. There are iron meteorites. There are, even in Namibia, one more Gibeon is one more crater, which is about 26 tons. You can well imagine a 26-ton rock coming and hitting the ground. What kind of vibrations it will be creating. So then I will show you one more slide here, Amrutanshu, of the felt meteorites. Professor Bhandari has already shown you about Shikoti Island, which was around 23 tons. And this particular meteorite is an iron meteorite. One of the methods that we have been following at Asteroid Day, we do make it a point to show you a larger piece of Shikoti Island, where to hold it in hand itself, it's so heavy, it's around 15 to 20 kilos that you have to hold it for Shikoti Island. Similarly, most of these Allende and the other meteorites, one can see it. We have also made a small presentation during the Asteroid Day, where we have shown meteorites which have fallen all over the world, and that we have done it as an audio visual. So I would also request our participants to see these things. And then we go further. I have to bring to your, I think one more slide is there. 2 slides more are there. This is the Barringer crater, and you will see it doesn't have water in it, but you will see here some reel-like structures all around that. Even in Lonar, you do see this. And in some rocks, you see them as shatter cones. Shatter cones are something which are very, very important to look for meteorites. And here you can see the diameter of it in Barringer and the kind of radiations. One can really today record all these signals which are passing through, and you can still get the remnant shocks where it has come. You can definitely see that. And there are equipments over there in that part of the world. We should also look at those possibilities of looking at equipments wherein we are able to look at different materials. In fact, at our Akashganga Center, we have also acquired a metal detector to see how far we are able to pick up meteorites from. So we are using 2 types, a metal detector, which is called as a mine detector, and the other one, we have a smaller one, which is called as a probe detector. And the amount of the magnet that you normally tend to use it in your school labs is about 600 Gauss, or maybe less than 400 to 600. But if you go for a better equipment, like you get neodymium magnets nowadays, they are very strong. They are around 4,000 to 6,000 Gauss. And you can use them also to detect meteorites. Can we have the next slide, sir? Yeah, this is one interesting thing that we had to point out. This meteor which fell was during September 2003. And what had happened, this event happened in Odisha because we met a lot of witnesses around, right from Bhubaneswar to Baripada and then Kendrapada, Sudsurya, all these places. But this place which we went was called as Sudsurya. And in Sudsurya, this poor man's hut, the roof of the hut was completely burned by the fragments of that boloid which passed over this hut. And where we were able to pick up the meteorite samples were in his kitchen, where he's showing. And this is the person who actually saw that event, boloid, happening right above his head. And you will see later when we went, he had to cover the hut with a plastic sheet to see that there are no more rains coming in. And this is what was the meteorite which was picked up in Kendrapada. This was the Tehsildar who had picked up it was there in their treasury, and we were able to go there, and this was the meteorite which had fallen in Kendriyapada. Kendriyapada was one place. There were nearly 13 to 14 districts where this had fallen. And at one place where we were, which was called as Paschim Sunit, and there we actually could see a crater made by a meteorite, but as it went down, it was moving like a bore wheel. And it was, here you can see those kind of features, and the grass around was completely burnt. It was a rainy season, remember this. It was a rainy season, and this had happened there itself. Besides that, it had fallen. In fact, the people who were there with us, they told us they had to rush inside the house, and the rain over there was of stones. So their metal roofs were actually rattling due to these stones falling on their huts. And this is where one meteor fell right inside a paddy field, which went all the way down to 30 feet. Please remember this, 30 feet. And what we have put here is a bamboo stick to see how low it had gone. But we could not recover this particular meteorite because it was a paddy field and it was filled with water. So there we could not. But when we came down to Pura Suniti, there we were able to pick up a lot of samples. And this is where we said that it has not fallen only in Kendrapada, it has fallen over an area of about 33,000 square kilometers. And the samples which we were able to get were also from not only from Sudsurya, but Baran and other places. So this is one observation which one can do it from any place that you have. We are in the process of making more of this, and I have given you meteor observation softwares. If those of you who are interested in actual photographing and then trying to analyze, these are the softwares which are free, and only UFO capture is from Japan, and it's little very expensive, costing nearly 17,000 rupees. But this one, GHOU, is a free software which anyone can use. Besides meteor observation from the visual and of the optical point of view, we are also looking at the radio part of it. Can we have this? In the radio meteors, there are two programs which I have shown you here. Meteor V40, and there is a software also called Telegram. Now you can take the feedback which you can get on. Nowadays you have what we call it as software based pen drives, on which you can take the signal from the antenna and then you can give it to Meteor 4 or Telegram and then find the meteors which have come. And remember one thing, meteors don't come just like that. As Professor Bhandari already had mentioned, there is a whistling which you can hear even on your radio FM. Now, our FMs are all tuned between 90 megahertz to 110 megahertz. You have to make a Yagi antenna, simple earlier Yagi antenna, and then use it for looking at radio meteors also. You can find the fragments also of the meteor as it comes down, and you are able to record it. I think I will stop here and look forward for some question answers.
So, thanks all. Friends, as we have already heard from Narendra Bhandari sir and Adur sir, Bhandari sir, I would request you to kindly unmute yourself. There are a lot of questions and the chair, Handa sir, is also here. So I forward the reins to the chair for the discussion part.
So, any comments?
So there are a lot of queries which I can see from the participants in the chat box.
So read the chat fields from the bottom. So the first one is from Iria, and how can we expect rocks distinguishing from planets and the moon come to Earth or landing on other planets and asteroids?
Bhandari sir, I hope that this question is directed to your talk, sir.
Yes. Yeah, you see, there's a rock, a big rock, if it falls on moon or other planets, then it kicks off lot of material, and if that ejecta material acquires a velocity which is higher than the escape velocity, then that material is thrown into interplanetary space and then it arrives at the Earth. So moon is very close to Earth. Anything which comes out of the moon is swept by the Earth very quickly, because Earth is a giant, bigger planet, I mean in size and gravity. So it collects all the material. It is like a, you know, broom collecting all the material coming from moon to the Earth. But Mars is little difficult. There the escape velocity is 5 kilometers per second. But in any impact, because it is very close to asteroidal belt, in any impact there is a little cone where all the velocity is concentrated, and some rocks can escape Mars and eventually reach the Earth. So it is a multi-stage phenomena. It is not just one stage. Something comes and kicks off, like you kick off a football, and then it goes to the Earth and falls here.
So that means the escape energy, kinetic energy, it came from the previous meteorites on other planets.
Right.
So I think it should be some energy concentration to the small body from the falling on the meteorites, original meteorites. So is there any mechanism, say, concentrates kinetic energy?
No, you see that energy, the kinetic energy is divided into several phenomena. One is the heating of the target. They melt The other is ejecta, it is thrown off. And the third is it just breaks sometimes in the air itself. So all this, if it has an atmosphere like Earth, so this energy which comes in is divided into three parts, and that way we are lucky that we have atmosphere, so nothing comes and hit us. But if you are on moon, you can see what kind of surface is there.
And the next or the previous question is should be the same. The answer from you. It's how can meteorite travel from Moon or Mars? Are they coming from the land of such celestial bodies, or they are just rock removing their planets or satellites? So you've already answered this question.
Yes.
And the previous one is from the area. During your earlier presentation at Nehru Science Center, Mumbai, you had shown the meteorites both from Luna, Kuch. Have you conducted any further investigation on it, sir? I remember seeing the meteor sample other day. Professor Bhandari was not convinced about your claim of lunar crater. Any concrete evidence you have about it? So
this is a query aimed at Bharat sir, to be followed by Bhandari sir, because you both had conflicting argument over that lunar crater in Gujarat, Kutch. So, and Narendra sir, you can take this as an opportunity to explain the procedure also, that how a crater gets confirmed. So, the Bharat sir and then Narendra sir. Bharat sir, please.
Yeah. Now we had conducted 2 field trips at Luna in Gujarat, near Kutch, where we had conducted these, and then we were able to collect some samples, not many, but some samples. And then we had conducted with the students to find the rim of the crater. Since the crater rim is very, very shallow, and there are now in last 2-3 years, we've been seeing that it gets flooded. So water is also there. Hence, the crater's rim has eroded in the last 3 to 4 years. So this is one part of it. Now about the sample part, we are yet to get the samples analyzed. We have only done one sample in which we have done only petrography of it, but it is not completely indicative of a meteorite crater or meteorite. Hence, we are awaiting for that, because we are using different methods to study this, and hence we have not got the complete data. Hence, we are only saying it is a crater which is a suspected crater. The diameter is around 2 kilometers, the circumference of it, and it is not at Mota Luna, it is at Nana Luna. So there is, in Luna also there are 2 places. One is called as Mota Luna and another is called Nana Luna. This crater that we had used it for studies was also shown to us by Professor Mahesh Thakkar of Kutch University, and then he also had said that it needs more studies to be conducted at this particular crater.
And sir, your opinion on the same, please.
Yes, I will like to add that there are 4 or 5 well-identified demonstrated crater in India. One, of course, is in Maharashtra, that near Ajanta caves. The other is in Rajasthan, that Ramgarh crater. A third one is in Kaveri Delta, Kaveri River Basin. and the fourth one is this Dhala crater in Maharashtra. So there are many ways a crater can be formed. But the definite characteristic of an impact crater vis-a-vis a volcanic crater or a erosion crater or a collapse of a dome or many other phenomena is that a impact crater has a raised rim. The rim is raised, as Dr. Bharat Adur showed in his demo, that the waves come out, so the whole crater is lifted up around the rim. And in the ejecta gives a reverse stratigraphy. That means what is below has come up and what is up has been buried. So that reverse stratigraphy, the raised rim, then the ejecta falls outside and you should be able to find the meteorite fragments there. And in the center of large craters, you have a central hill. So all these four criteria make a crater an impact crater vis-a-vis a terrestrial crater. There are many ways a crater on the earth can be formed. And when I visited the place, I did not find any such evidence because partly because the terrain is such, it is loose soil and it erodes and fills with water and all that. But nonetheless, I did not find any of these four features which identify a impact crater. That is why I don't know, but I guess I'll agree with the Dr. Adur that more work is required. So let us join and investigate it further.
So that in your answer, I found not only the meteorite itself, but also its situation, like the crater shape or the material around the meteorite itself, is also important.
Yes, of course. For large craters. For large craters.
Say a few years ago, one of Japanese person recognized the meteorite is very precious. So they use some machine for digging around that. So all the evidence is vanished. So that is very sad story. But say so, if you if anyone finds some hint of the meteorites, then at first to take photo around there and record every phenomena around that, and then to find out the meteorite itself. Is it appropriate procedure?
I agree fully with you, and actually I've been going to this Maharashtra crater and somebody has built a road around on the raised rim. So all the evidence is gone. So it should be, as soon as a good crater is there, it should be declared as a heritage site and it should not be touched. That is very important because in future there may be techniques by which we can learn lots of things. So now I find there is about 15-20 feet road all around that crater with a 2 kilometer radius, and you can't find anything which we used to find in the very beginning when the road was not there. I fully agree with you, sir.
Okay, thank you. And the another question is how to identify the origin of the meteorites coming from the certain portion of the constellation. That means which planet or the moon, the origin of the meteorite. How to identify it?
Well, there are many ways. One is but we need a certain information about that. One is the radiant of the meteorite, where from it has come. And there is that means the zenith angle, the azimuth angle, and we must know the velocity. Velocity is very important because this velocity gets changed by the Earth's gravitational field, and therefore we have to work backward and see what was the velocity in space. So there are programs in spherical coordinates where you put in all these things, And what we did is we found a way of determining the velocity after the meteorite has fallen. And that comes from the fact how much of it has burned. The amount of meteorite, burns in the atmosphere depends on the velocity, as a square of the velocity actually. So it is very sensitive to velocity of the meteorite in space as it enters and as it slows down. So by doing some what we call nuclear tracks, we can find out how much material has been ablated, and then what should have been the velocity. So there are two ways. One is to photograph the trail, the fireball, with a shutter to get the velocity, and that is done. There are many networks which do this in the world, and other is after recovery you can find the velocity. And the third technique is to take the spectrum of the interior of the meteorite and compare it with the asteroid's spectra and see which one matches. So there are these three techniques have been used, but the best thing is if you have lots of eyewitnesses, then they can tell from which direction it is coming, and there is a camera which has measured the velocity, then I think it is very good to get a good velocity.
So in these days, many people has a camera with their smartphone. So it is easily to gather many images or the movies from the multi-point. So that should be helpful to trace the velocity of the meteorite.
Right. And there is also a design, a wide angle camera which looks at 180 degrees of the sky with a shutter which is computer programmed, so that it's closes, opens, and you can get velocity for every fraction of a second. So that is more precise.
So that another question is maybe related to my comment. From the Srivata what analysis can be done after seeing a meteor shower with naked eyes?
No, meteor shower is different. That is very fine particles, less than millimeter. So that you can get the spectrum and take out the glow lines of oxygen and nitrogen, etc., and you can find out the composition of meteor. So that is one thing which can be done. But meteorites, the situation is different. We can do lots of analysis on meteorites, chemical composition, isotopic composition. Then we can do cosmic rays. We learned from meteorites that cosmic rays were there 4.5 billion years ago. There is no other way to know except through meteorites, that the effect of meteorites are there in the effect of cosmic rays are there inside meteorites which were 4 billion years ago. So this lot of information can be obtained, and we have a handbook and we have a handout. A handbook is for field observation, what information one must fill. A handbook gives you all the data you must collect during your expedition, and then of course it should be sent to a good laboratory for further analysis.
Okay, thank you very much. There are many other questions and comments in chat field. Please read it, and it's possible to get the answer on the chat field. But unfortunately, it is the time is up, so this workshop will be closed. It's a very interesting, and many people stimulate the meteorite study is a very important and very interesting. So thank you very much.
Sir, I just want to make one comment that this is ideal project for participation of citizens in a good science. in which a lot of people all around the world can take an active interest, because it cannot be done by individual laboratory scientists. There's a lot of field work. So this is an ideal project, and I invite you to contact me and also read my book, which is called Falling Stones and Secrets of the Universe. This is a small book, has more details. Thank you very much.
Thank you very much.
Thank you very much, everyone, for today's fruitful workshop and also session.